When I do the derivative, I get y equals 1/2 times, just leave all this alone, change the power, reduce it by 1, so that gives me a negative 1/2, times, follow the chain now, the derivative of 20x is 20, minus the derivative of x to the 7th is 7x to the 6th. And then I can just clean this up a little bit. The derivative would equal, let's see, the stuff that's on the top is the 20 minus 7x to the 6th. And the stuff that goes to the denominator is the 2. And the root, same as the half here, the root 20x minus x squared. That's my answer for number 1. Any questions there? Our next problem is number 2. I'm going to think of that as y equals 1 plus sine 10x. That's sine of 10x, all to the 1/2 power. Some of you guys just kind of lost the 10 or lost the x along the way on here. It's got to be, the whole thing's got to kind of come into play here. So the derivative is 1/2 times everything that's inside still. And then we reduce the power by 1. That will take us to negative 1/2. And then multiply by the chain. Well, the derivative of 1 is 0, so forget about that. The derivative of sine 10x, there's a chain involved there. The derivative of sine is cosine, so that would be cosine 10x, times the derivative of the 10x. There's a chain involved in this because there's a 10x inside the sine function. The derivative of that is 10. So let's see what we have in the numerator here. I've got a 10 cosine 10x. And the denominator, I've got a 2 times the square root of 1 plus sine 10x. I'm going to go ahead and reduce this 10 and this 2 so that I get a final answer of 5 cosine 10x all over root 1 plus sine 10x. Any questions here? Concept is implicit differentiation. We're going to find the derivative of this function and leave it in terms of x and y if applicable. So the derivative of this function implicitly, 3y squared, the derivative would be 6y, but we have to follow the chain on that and get a y prime, minus the derivative of 7x squared is just 14x. The derivative of 13 is 0, and that still equals 0. In order to actually find the derivative, I have to isolate this y prime. In order to do that, I'm going to add 14x to both sides, so 6y y prime equals 14x, and then divide by 6y. So y prime equals 14x divided by 6y, and we'll go ahead and reduce. Y prime equals 7x over 3y. There's my implicit differentiation for number 3. Any questions here? Number 4 wants a little more work. They want us to find the first and second derivatives. So we'll go ahead and find the first derivative, similar to number 3. The derivative of 2y would just be 2 times the, follow the chain would give me the y prime, minus the derivative of x is 1, plus, I need to be careful with the xy, that's a product. So I'm going to keep the x multiplied by the derivative of y, plus, following the product rule, I'll keep the y multiplied by the derivative of x, which is just 1, so that gives me y, equals the derivative of 3 is 0. Now in order to get this completed, I need to isolate this y prime term. So I'm going to keep the 2y prime and xy prime on the left and move everything else to the right. So if I add the 1 to the right, I'll have a 1. Subtract the y from both sides, I'll have a minus y. If I factor the left, I've got y prime times the quantity. I could write it as 2 plus x or x plus 2. I'm going to choose x plus 2 equals 1 minus y. If I divide by the x plus 2, I get y prime is equal to y minus 1 over x plus 2. There's my first derivative. All right, let's go find that second derivative. I'm going to make some space here. So finding the second derivative, we just find the derivative of this thing. So the second derivative is the derivative of this thing, which means I've got to follow a quotient rule. So I've got x plus 2 squared, keep the x plus 2, multiply by the derivative of 1 minus y. The derivative of 1 is 0. The derivative of negative y is going to be negative y prime, minus, keep the 1 minus y this time and multiply by the derivative of x plus 2, which is just be 1. This is a bit of a mess. I'm going to replace this value right here, this y prime, with what it's equal to. It's equal to 1 minus y over x plus 2. So let's go ahead and write that step out. I'll keep my x plus 2 quantity squared in the denominator. I've got x plus 2 times the opposite of y prime. I'm going to let that opposite just come out here. Y prime is the same as 1 minus y over x plus 2 minus 1 negative times a positive, or negative times a negative is a positive, plus y. Notice that these reduce out right here. The x plus 2 and the other x plus 2 just reduce out. So I've just got to be careful with this negative sign now that's been around since the beginning of this step. So if I'm careful with that, I can clean up the numerator. I've got x plus 2 quantities squared in the denominator. I've got a negative 1 minus 1, that's a negative 2. And I've got a negative y, so that's a y, plus a y is 2y. So I've got 2y minus 2 in the numerator and x plus 2 quantity squared in the denominator. I could choose to write that as a factored out 2 minus 1, y minus 1 over x plus 2 quantity squared. Either one of these will work. That's my second derivative. Any questions on either of those? Take a look at number 5. Number 5, water is falling on the surface, wetting a circular area that is expanding at a rate of 6 square millimeters per second. How fast is the radius? Let's get that down. How fast is the radius of the wetted area expanding when the radius is 105 millimeters? Round our answer to 4. Some of you guys had trouble getting 4 decimal places. How fast is the radius? So let's see. I'm given that the area is expanding, so that's dA dt at 6 millimeters squared, or 6 square millimeters per second. And what they want to know, the unknown, is what's dr dt? That equals what when r equals 5? 105. Well, I just need to come up with a function that relates area and radius. The area function does that. Area equals pi r squared. Derive both sides. dA dt is equal to 2 pi r dr dt. dA dt is known to be 6. 2 pi. The radius at the time we're interested in is 105. And then dr dt. So according to the algebra here, dr dt will equal 6 divided by 2. I'll just write the whole thing. 6 divided by 2 pi times 105, which is approximately 0.0091 millimeters per second. Any questions here? 6. Ladder slipping down a vertical wall. The ladder is 17 feet long. The top is slipping at a constant rate of 2 feet per second. That's going down. How fast is the bottom of the ladder moving along the ground when it's 8 feet from the wall? Draw a little diagram of this. Here's my wall. Here's my ladder. And probably the floor is somewhere in here. My ladder is 17 feet long. I'm going to call this my y distance, this my x distance. This is a right angle, assumed a right angle. We're given that the rate that the ladder is coming down the wall is 2 feet per second. So that's dy dt. That's how fast my y variable is changing. It is negative because decreasing, good. And the unknown is dx dt when x is 8. So I need some function that relates x and y in this diagram. Pythagoras seems to work really well in these cases. So I've got x squared plus y squared equals the constant 17 squared. If I derive that, I get 2x dx dt plus 2y dy dt is equal to the derivative of 17 squared is going to be 0, which is nice. I can divide the 2's out, and I can start substituting. X is 8 at the instant we're interested in. Dx dt is unknown. Plus y at the instant we're interested in we haven't calculated it. The instant we're interested in, we have an 8 here. Pythagoras or Pythagorean triples will tell us that y will be 15 at this instant. 8, 15, 17 is a triple, or 17 squared minus 8 squared and rooted is 15. So the y value is 15. dy dt is negative 2. That equals 0. I'm solving for dx dt, trying to get that by itself. So if I have a negative 30 here, if I add it to the other side, I have 8 dx dt is equal to positive 30. If I divide by 8, dx dt is 3.75 feet per second. Any questions there?